Okay, I am going to take a couple of minutes and walk through letter A. I believe it's problem 11 in the review questions, because I want you to see the difference between the Lewis structure and the molecular structure, or the the geometric representation. So we're going to walk through how I would go about solving this particular problem, and hopefully this will help things make a little bit of sense. So let's go ahead. So in order to figure out what the geometric shape is, you have to start by figuring out the Lewis structure. So I'm going to start by looking at the Lewis structure of each of the individual atoms. And we have both silicon and chlorine. I've got 4 chlorines, 1 silicon. The name of that would be what? It would be silicon tetrachloride. Okay, so we know silicon is in column 4A. That means it has 4 valence electrons, which you can see I've drawn by the 4 dots around the silicon. Chloride is in column 7A, which means it has 7 electrons. And you can see that I have drawn 7 electrons circling the chlorine atom. So to make the Lewis structure for this, how would I go about doing that? Remember, I'm always going to put the element with the most unpaired electrons in the center. Silicon has 4 unpaired electrons, chlorine has 1. So silicon goes in the middle, and I surround it with the 4 chlorines. You can see I've got lots of dots on here, but I've got the silicon, its 4 electrons, and then the 4 chlorides, or the 4 chlorine atoms around it with their 7 electrons each. So then I can go ahead and draw a Lewis structure, which looks like this. Okay, so we've got silicon, and the silicon has 4 bonds with each of the 4 chlorine atoms that surround it. So this would be the Lewis structure. Now, from the Lewis structure, you can figure out what the geometric representation is. And the way you do that is by looking at the number of things that surround the central atom. In this particular case, we have 4 bonds surrounding the central atom. That means that this particular compound would be in the tetrahedral family, and the shape of this would be a tetrahedral shape because there are 4 things that surround the central atom. When I go to draw the shape of it, I'm going to draw something like this, okay? Now, what is the difference between what I have drawn here for the shape and the Lewis structure? Well, you can see that I have not put the electrons on the outside of the chlorine atoms in the shape. When you draw the geometric shape, you don't have to put the electrons that are surrounding the outer atoms, okay? You're also going to draw, you're going to take a guess at which element has a higher electronegativity. Now, if you remember, our electronegativity is going to go its highest as we go to the right and as we go up. It turns out that silicon and chlorine are in the exact same row, and chlorine is further to the right. So chlorine's going to have a greater electronegativity. So we show that simply by these arrows, the way the arrows point. So we're saying that the electrons are going to spend more time circling the chlorine atoms than they would be circling the silicon atoms. So that's what the geometric shape would look like. And then we would classify this as a tetrahedral shape. We classify it as a tetrahedral shape because there are 4, let me get a pen here. There are 4 sets of electrons, 4 sets of electrons surrounding the central atom. And I'll show you where those are, okay? This is, if we go back up here to the Lewis structure, there's 1 pair of electrons that surrounds the silicon. There's another one here, and another one here. So this is in the tetrahedron family. And we would classify it as a tetrahedral shape. So that is the difference. What you can see up here basically is the difference between the Lewis structure and the geometric shape. The Lewis structure has all of the electrons, the geometric shape does not. And Hopefully that is somewhat helpful to you. If anyone has questions, you're welcome to reach back out, but that would be the difference between the Lewis structure and the geometric shape.